Okay, so today we're going to work on a set of notes on what we're going to call a line of best fit. Okay, so this relates to our idea of a scatter plot. Okay, so what we've got is we're going to hope that we have a scatter plot that has some sort of like correlation where the explanatory variable on the x-axis and the um, what's it called? The response variable on the y-axis seem to have some sort of relationship, and we're hoping that that relationship can roughly be modeled as a line. So if the relationship exists, we say that it has correlation. If it looks like that you could model it by using a straight line, we would say that it has linear correlation. And if we can do this, we would like to be able to stick some sort of line through there that can be used to model this. Okay, so we're going to call this thing a regression line. Okay, so this is the line that best fits this data given a certain cost function. Okay, um, now what we're going to come up with is a thing called a linear regression or linear correlation coefficient. Okay, so there's a number, and we're going to call that thing R. Okay, and R is always going to be between -1 and 1. And the further that that number gets from 0, the better this line, the tighter you have correlation here, the better you have linear correlation, the better that the line fits everything. So if I have like a 0R, this means that I have like no correlation whatsoever. If I'm -1, I have correlation, but it's going in the negative direction. If I have 1, it's going in the positive direction. Okay, so this is a number that we're going to use, and we're going to see how this plays into things. I think that the best way to handle all of this is to actually work through an example. So what we're going to do is create an example here. All right, and in our example, I'm going to put some data into L1 and L2 in my calculator, and then create a scatter plot, and then create one of these lines of best fit here. So let me make my calculator fit the screen here so you can see everything. Probably if I do something like this. There, oh, no, that didn't work. So let's make that fit. That didn't work. Oop, that's not what we want. Alright, so after a little bit of off-screen magic, we make the calculator fit here, right? So what I'm going to do here is I'm going to go into my stats, edit, and I'm going to just clear this all out because this is old data. I don't want that in there anymore. So let's get rid of all of that. Clear 3, clear 4. Alright, so it's all cleared out. Great. Now, I'm going to make a assumption here that, like, when the jackpot on the lottery gets larger, then we're going to sell more tickets. That's my assumption. So let's put in L1 the amount in millions of dollars that you could win for, let's say, Powerball or something like that, right? So, and this is the amount that you would win if you hit the Powerball. All right, but this is not in dollars. This is like millions of dollars, right? There you go. So $334 million. And then what's going to happen is we're going to look and say, well, how many tickets would we sell if that was the case? So like 334 million in the jackpot. Let's say we sell 54 million tickets, right? Because that jackpot's been growing for a while. 16 million here, 41 million here, 27 million here, 23. Oops, that's not right. 41, 27, 23, 18, 18, 16, 26. These are all in millions as well, right? So the first column is like millions of dollars in the jackpot. The second column is millions of tickets sold, right? And that we're going to say that the jackpot's going to be amount is going to be the explanatory variable because it's going to increase or decrease the number of tickets that we have. All right, so let's get a scatter plot on this, right? So let me go y equals, make sure there's nothing in there. All right, so let's turn plot 2 off. We don't want that one on. All right, so, and then we want to turn plot 1 on, right? So plot 1 is a scatter plot. It's list 1, list 2. We're going to use little crosses, use blue. So I'm going to go zoom 9, and there's my data, okay? Now, it's got a little curve to it, but, you know, generally speaking, it's increasing. It seems to have a pretty strong correlation. Now, what I'm going to do is I'm going to make a line that fits that data, okay? So we're actually going to have the calculator come up with a model that might fit this, right? So a quick caution, I'm going to change make sure the mode of my calculator has the stat diagnostics on, because I'm going to get more information when I run a regression. So I'm actually going to leave that on. Okay, so I've done that. Stat, I'm going to calculate the linear regression. Now, there's two options for linear regression here. There's number 4, which makes A the slope of the line. There's number 8 that makes B the slope of the line. In algebra, I know that you use this one. In stats, we tend to use the number 8 one, where it's the intercept plus the slope. So we're actually going to use number 8 here. And I'm going to do this with line 1 and L2. And I can get a little tricky here. I don't have a frequency list, so I don't need to add in there. But it tells me, where do I want to store the regression equation? Well, I want to put that in y1. So when I graph, it actually shows up on the screen. So I go to vars, and it's a y-var because it's y1, so it's a y-var. So I'm going to put that into functions. And there's y1. So it says store the regression equation in y1. Now I'm going to calculate. Now, this gives me some information. This R down here, the 0.94, is really close to 1, which means that my data has a strong linear correlation, which means I'm doing a good thing by trying to model this with a line, okay? And if I look here, my slope is negative 10.8, so really 10.9, not my slope, my intercept, negative 10.9. My slope is around 0.174. Okay, so that's going to hit my line of best fit. If I hit like y equals, you look, and it just stored that whole line of best fit right there. I don't have to copy it anywhere. It's there in the y1. So go ahead and I graph, and there's the line. That's the line of best fit. So this data can best be represented with this line. Now, we're going to see a little bit later on, once I have this line of best fit, right, I can use this to make some predictions about this using this data. Okay, so we're going to be able to do some inferencing here and be able to make predictions about, like, well, what if the jackpot was like 200 million? Then how many tickets should I expect to be selling, and those kind of things. That way I can make some pretty serious estimates about stuff. All right, so there's your basic idea of what a line of best fit is, and we just use the calculator to create one. We're going to do some work with this in class over the next several days. So, cool. There we go.